work and energy, potential and kinetic energy. Energy is the capacity to do work. You can use energy to do work immediately or you can store it for later use. Does that seem a bit complicated to understand? Let me make it simpler for you. Look at this stone. It is lying on the ground. Can it do anything? Not right now. It is on the ground level, so it has no energy. Now, let us lift it up and hold it like this. What just happened? The person did work to lift it up, right? Of course. The person used force, muscular force, and picked the rock up from the ground to this height. There was force used and there was displacement. So obviously work was done. So energy was used because we know that energy is needed to do work. Where is this energy? The energy is stored in the rock. Let me show you the energy in the rock. Let's put a piece of chalk on the floor just right here. Now you know what will happen if you let go of the rock. It falls on the chalk, crushes it, and makes a noise too. So, the rock does work of crushing the chalk and making a noise. Now, let's go back and understand what happened in each step. When the rock was lying on the floor, it did not have the capacity to do work. Then, we picked it up and took it to a height. To do this, we had to use our energy and do work. Where did that energy go? It got stored in the rock. When we let go of the rock, it actually used the energy that it had stored and used it to do work. Once it came back to the ground, the energy was used up. So again, the rock that is on the ground has no energy to do any work. When we do work on an object, the energy that we use to do that work gets transferred to the object. The energy that is stored in an object is known as potential energy. The object can now do work because of that energy. What if we lift the rock to double the height? We have done more work as the displacement has increased. Some more energy is stored in the rock. The rock that is at a greater height has greater potential energy. So the rock that falls from a greater height can do more damage as it has more energy and can do more work. You may have played with clockwork toys when you were little. This toy that is just standing here has no capacity to do any work. It is just standing there with no energy. Now, wind the spring. You have to do work to wind the spring, right? You use muscular force to wind the spring. So your energy goes into the spring. Now, this energy is stored in the spring. When you let go, what happens? The spring uses the energy that is stored in it and makes the toy move. So, now the toy is doing work. the toy continues to do work till it has used up all the energy stored in it. What happens if you wind the spring only a little? The toy will have lesser energy stored in it, so it will do less work. If you wind the spring more, the toy will have more energy stored in it, so it will do more work. This stored energy is potential energy. Have you used a catapult? You can make a simple one using a rubber band. Just hold your fingers apart and try to catapult a small eraser piece. You just have to hold the rubber band like this and the eraser in it this way. Now remember, we are doing this as a science experiment. You should not do this to trouble someone. You should also not use objects like pebbles or stones that could hurt someone. Okay, back to our catapult. When you stretch the rubber band back, you are doing work which is getting stored as energy in the rubber band. When you let go, the rubber band converts this energy to work and throws the eraser far off. So again, you see energy being stored which can do work later. You know what we call this energy. We call it potential energy. A ball that is just standing on the ground has no energy. It cannot hurt you. But a moving ball can hurt you if it hits you. Why is that? It is because all moving objects have energy. The energy that an object has due to its motion is called kinetic energy. When do you think this ball will hurt you more? When it is moving fast or when it is moving slow? Obviously, the ball will hurt you more when it is moving fast. So, it means that when objects move faster, they have more kinetic energy. The energy that an object has due to its motion is called kinetic energy. The kinetic energy of an object increases when its speed increases. You all have definitely played on a slide. You had fun climbing to the top and then sliding down, whoosh! What you probably didn't know is that it is an excellent example of conversion of energy. What happens when you climb to the top of the ladder? You are using your muscular force and working against gravity. You are also moving from the bottom of the slide to the top of the slide. So, you are using force and displacement is happening too. Hence, work is being done by your body. When you climb to the top of the ladder, you have a lot of energy stored in your body. As you know, this is potential energy. Now, when you slide down, you gather speed as you move down. The potential energy stored in your body is used to give you that speed. When you are moving down, you have energy due to your motion. This is kinetic energy. The potential energy that is stored is converted into kinetic energy and used up as we come down the slide. If you climb up a small slide, you store less potential energy, so you have less speed as you come down and less kinetic energy. If you climb up a tall slide, you store more potential energy, so you have more speed as you come down and more kinetic energy. When you throw a ball up, can you understand the kinetic and potential energy transformation in the ball? When you throw it up, you use muscular force to do work. The ball uses this energy to keep moving up. So, the energy from your body gets converted into kinetic energy and gives the ball speed to move up. As it moves up, its speed decreases. Because the speed decreases, it means the kinetic energy is decreasing. But the ball is going higher and higher and higher. So, the potential energy of the ball is increasing. Hence, we see that the kinetic energy of the ball is getting converted into potential energy as the ball is rising up in the air. Now, as the ball moves higher, it slows down. When the speed of the ball becomes 0, it stops moving up. The ball is at the highest point. The kinetic energy is 0. The potential energy is maximum now. Then what happens? The ball has no choice but to start coming down. Let's look at how energy changes for the return journey. At the highest point, the kinetic energy is 0 because the speed of the ball is 0. The potential energy is maximum because the ball is at the highest point in its path. When the ball is moving down, the height of the ball from the ground reduces, so the ball loses potential energy. When the ball starts moving down, again the speed of the ball goes on increasing. So the kinetic energy of the ball goes on increasing. Do you see what is happening here? Potential energy is getting converted into kinetic energy. When an arrow is shot, what happens? Potential energy is stored in the arrow string when it is pulled back. When the string is released, this energy is transferred to the arrow. The arrow converts it into kinetic energy and shoots ahead with great speed. So, we see energy conversions all the time. Potential and kinetic energy together make up mechanical energy of the object. What did we just learn? The capacity to do work is called energy. If an object has more energy, it can do more work. If it has less energy, it will do less work. Energy can be used immediately or it can be stored for later use. Energy stored in an object is known as potential energy. An object has potential energy because of its position. Energy that an object has because of its speed is known as kinetic energy. Potential energy can be converted into kinetic energy. Kinetic energy can be converted to potential energy. Potential and kinetic energy together make up mechanical energy of the object.